Hi everyone. In today's Fundamental Skill Builder series on the subject of organic chemistry, I'll be teaching you drawing the Lewis dot structure of an atom. And to walk this through, let's take a look at an example. Draw the Lewis dot structure of A, a boron atom, and B, a nitrogen atom. Since in a Lewis dot structure only valence electrons are drawn, we must first determine the number of valence electrons in each atom. Boron, which is in group 3A of the periodic table, has 3 valence electrons, whereas nitrogen is group 5A of the periodic table, has 5 valence electrons. Next, we're going to place 1 electron by itself on each side of the atom. So since boron has 3, we're just going to place 3 by each of the 4 sides, and with the last side having none. Nitrogen has 5, so we're going to place the first 4 by each of the 4 sides. What about the last 5th electron? So if an atom has more than 4 valence electrons, we're going to place the remaining electrons paired up with any of the electrons already drawn. So we're free to put the last 5th electron on any of the 4 sides to be paired up. And to walk through this exercise, draw a Lewis dot structure for each of the following atoms: carbon, oxygen, fluorine, hydrogen, bromine, sulfur, chlorine, and iodine. So let's begin. The first one is carbon. Carbon, which is in group 4A of the periodic table, has 4 valence electrons. The periodic symbol for carbon is capital C, and therefore, since it has 4s, we're just going to place 1 on each of the 4 sides. Next, we have oxygen. Oxygen belongs to group 6A of the periodic table, and therefore it has 6 valence electrons. The periodic symbol for oxygen is capital O, and since it has 6, we're just going to place the first 4 around each of the 4 sides, and then place the last 2 on any of the 2 of the 4 sides. So it will look like this. Next, we have fluorine. Fluorine is in group 7A of the periodic table. Therefore, it has 7 valence electrons. The periodic symbol for fluorine is capital F, and we're just going to place the first 4 around each of the 4 sides, and then pair up the last 3 with any of the 3 sides, and so it will look like this. Hydrogen is in group 1A of the periodic table. Therefore, it only has 1 valence electron. Not many elements has 1 valence electron. The alkali metals, well, hydrogen is the only nonmetal in that group that is considered to be part of organic chemistry. So we're just going to play 1 dot like this. Bromine is in group 7A of the periodic table. Therefore, it has 7 valence electrons. The periodic symbol for bromine is capital B, lowercase r, and this Lewis dot structure will look exactly like that of fluorine, since they have equal number of valence electrons. Sulfur is part of group 6A of the periodic table. Therefore, it has 6 valence electrons. The periodic symbol for sulfur is capital S, and since it has the same number of valence electrons as oxygen, it will look exactly just like oxygen. Chlorine is in group 7A of the periodic table. Therefore, it has 7 valence electrons. The periodic symbol for chlorine is capital C, lowercase l, and since it has the same number of valence electrons as fluorine, it will just look like that. Iodine, also just like the other halides, is in group 7A of the periodic table. Therefore, it has 7 valence electrons. Its periodic symbol is capital I, and since just like the other halides, it will just look like the same as chlorine, fluorine, and chlorine, fluorine, and bromine. So to recap, why did I do this? Just these 8 elements. And this is because in organic chemistry, it is about chemistry of carbon. And the majority of the organic compounds you will see as you progress in your future organic chemistry courses, that these 8 elements are the most common elements you'll ever find in organic compounds. So it is very important that you know how each atom, its Lewis style structures look like. It helps with bonding and polarity, things like that sorts of nature. So on your own, it says lithium salts have been used for decades to treat mental illnesses, including depression and bipolar disorder. Although the treatment is effective, researchers are still trying to determine how lithium salts behave as mood stabilizers. Part A, draw a Lewis dot structure of an uncharged lithium atom. In Part B, lithium salts contain a lithium atom that is missing 1 valence electron and therefore bears a positive charge. Draw a Lewis dot structure of the lithium cation. So if you could pause the video for a minute or two and attempt this problem and then continue on and see what the answers are. So once you've finished, here are the answers. And as you see, lithium is in group 1A of the periodic table. Therefore, it has 1 valence electron, as shown on the top. And if electrons removed from the lithium atom, therefore, it will have 0 valence electrons and will have a +1 formal charge. So these are some extra practices for you to do to consider about how important Lewis dot structures of atoms are in organic chemistry. I will not be posting these answers online, but if you want to check over them, you feel free to contact me. So I really hope this session really helps with the first series on Fundamental Skill Builder series. This is just the beginning part of organic chemistry, and as we build up, we're going to see how each of these fundamental skills are going to build up to develop higher problem level thinking. Thank you, and if you have any questions, suggestions, here's my contact info.